Hello everyone, so in this video let us talk about the second problem from the latest Codeforces Round 824, problem named Tea with Tangerine. So there are n pieces of tangerine peel. Okay, tangerine you can just assume to be some fruit. Okay, and it has different peels, that n pieces. Now the ith of them has size a of I. Now in one step what you can do is that you can divide one piece of x into two pieces. Okay, like you can just assume that you have different papers or tangerine, whatever, you can just assume different papers. At one step you can just, like, you can divide the piece into whatever division you want into two pieces. Whatever you want, you can just divide that particular piece into two pieces. Now that is one step. Now what you'll eventually have to do is that you have to divide all the pieces, tangerine pieces you have, into smaller pieces, such that if you take any pair of pieces after doing this operation, if you take any pair, like if you take two pieces among all the divisions that you have done, their size differs strictly less than twice. What it eventually means is that if you take out any two pieces, then if you just find out the size difference, okay, the smaller one should be always that, if you like just double the smaller one, okay, then the larger one among both of them should always be less than that. That's the overall thing. I will tell you with an example also, don't worry. And then you just have to tell that what is the minimum number of steps that are needed to satisfy this particular condition. Let's say, take this example, just always in such a problem, always do some look at the example. Okay, let's take this, or let's say the first example. What they have done is that in the first case, the minimum piece, like the first piece is 1. Okay, the minimum piece is 1. Now if I take this particular piece and pair it with any other piece, maybe just any other piece, then this is the smaller one. So if I just double the smaller one value, that is 2, so all the other pieces should be less than 2. That's the overall thing. I hope you get the point. So the thing is that if whatever is the minimum of all the elements that I have, okay, I just have to ensure that whatever is the minimum of all of them, other elements should be less than the twice of the minimum of the smallest value. Okay, that's the overall thing. So the basic idea here is that we just have to first find out the minimum value, and because it is in sorted manner also, it is given here. So it's very simple that you just take the first value, that is the most minimum value. You don't divide that particular value, you just take that this is the minimum value, and for all the other values just divide it in such a way that it should be less than twice this particular value. If I just take the smallest value, twice it, so if I just take the value and twice it, it will become, let's say, first value is, let's say, x, so twice of it is 2x, so 2x minus 1. Okay, that's the just a smallest value of the twice of the smallest value. Okay, just a smaller value of twice of the smallest value. I just got that 2x minus 1, that is the value. I just want that all the values apart from the first peel should be less than or equal to 2x minus 1. That's it. And how much operation that is required. That's it. So that's the overall thing that we'll do. We'll just take the first value. I'll just show in the code part. It's not too much difficult to grasp up. We just understand the code part and the logic. So what we'll do is that we will just iterate over. We'll just take the input of n, and let's say answer how much more operations have to do. Just take the input of all the tangerines here. So the thing is that because the first one is smallest, I just want that all the other pieces apart from the first one should be less than or equal to the smallest one. Okay, twice of the smallest one. So what value I want? So I just twice minus 1. So all the value should be less than or equal to this value. All the other tangerines should be less than or equal to this x value. So I have to divide those values. If they're larger, I have to divide this into this number of pieces. So let's say that I have one page, or let's say one tangerine of, let's say, size 1000. Okay, and I just want that any tangerine should be at max 100 length. So what I can do is that I can divide it into different smaller pieces of 100 size. So how much different pieces I will get? This 1000 divided by 100, that amount of pieces I will get. Okay, and this is the number of operations that I've also done. In one operation I'll just divide this into this whole piece. So to, like, one operation is done, then this whole is divided again into this piece and this piece. So I have to do at least like this number of cuts. Okay, this is the number of cuts or this number of operations. So this number of operations are done to just get the answer, and you just have to add them out. So you set it over all the other tangerines and just divide them. A of I divided by x, that's the number of operations that you do. The overall thing is that if it is completely divisible, that answer minus minus, what it eventually says is, let's say let's say if I have a tangerine of length, let's say 16. Okay, let's say it's 16 length. Okay, and the maximum I want, like the minimum tangent that I have, so that the length should be, I have to do at least a cut at 4 length. I don't want any tangent of length more than 4. So I will, how much cuts I will do? I will do one cut, two cut, three cut. After three cuts, I will get four pieces, such that all of them will be having of length 4. But because what I'm doing is 16 divided by 4, I will get 4 eventually. But no, I have done 3 cuts, not 3 cuts. After doing 3 cuts, the last one will automatically be of size 4. What I'm trying to say is that even if I do 3 cuts, all the lengths will be of 4 lengths. So what they are trying to say is that if it is properly divisible, okay, if the a of I is properly divisible by x, then I will just reduce my answer by 1. Why? Because the last cut is unnecessary. Let's say that it is of 17 length now. Then if it is of 17 lengths, so then I have to do 4 cuts. 1, 2, 3, 4. So that the first length is of 4. Next one is 4, next one is 4, next one is 4, and the last one is 1 length. Because I have to also do one more cut to just separate the last one out. But I just want all the pieces should be less than or equal to 4. So that is x. Like I just want all the pieces should be less than or equal to x. Because I've got the minimum value, that is the first value. Just do twice of that value minus 1. Because I just want that all the pieces, any pair that I want, because I can make a pair with the smallest value. And if I make any pair with the smallest value, I just have to ensure that for any pair, that all the pairs that I form, the larger one should be less than twice of the smaller one. Okay, if I just do a twice of the smaller one, the larger one should be strictly less than that. So the larger one should be strictly less than that. So whatever, what is the twice of the smallest one? This is this, and then all the other tangents, I just want to make this smaller than that. So I just do divided by that particular value, how much cuts I need and how much pieces I will get, or like how much operation I will do. That is the case in which it is perfectly divisible. So I just reduce my answer by 1, and in the end I just get how many operations I've done to get all the pieces less than that. That's the whole thing. It's just a greedy particular type of problem, and we have got answer in O of n. So that's the overall logic and the code part for the second problem as well. If you still have not, you can mention in the comment box of this particular problem. Thank you for watching the video till the end. I will see you next one. Like coding, and bye.